can somebody tell me what is it that you want?
Very interested in the wood pellet option, particularly with regard to how well does it function for heating purposes. What do you think are the ecological consequences? What do you think are the economic consequences of it? Any questions about supply, difficulties of supply or ease of supply for the pellets, for the equipment? In what cases or situations would you recommend doing an installation like this in the future, either college or at smaller even residential units or business? I think that's sort of the general kind of thing we're most interested in.
This is the Wiesmann boiler that we're going to see today. The vessel itself is made by Cobb. It's manufactured, and the system itself is manufactured and sold by a company called Wiesmann, and they're a very well-respected company. We have 2 Wiesmann oil burners, for instance, in another location on campus. We order from a company called Maine Woods Pellets. They are from Athens, and they deliver them here. They're loaded through an auger.
Do they deliver to other places, or is that just a special delivery here?
No, they deliver bulk and bags, so they sell every day. As far as ability to get them, we've never. We used Corinth 2 years ago, and our lead time was 3 weeks, and with Maine Woods, it's 2 days. We will use about 52 tons. We've used it. We filled twice this winter.
In terms of this part of the whole operation, do you have any problems with water getting in there?
Zero.
Do you have any problems with the auger mechanism
Zero.
feeding? Zero
Zero.
problems? And have you had
Zero. Nothing.
since the beginning? There were
Nothing.
no problems?
Absolutely nothing.
That's cool.
Absolutely nothing.
Yeah.
No, it's like getting oil. As I was saying to Dawn, it is literally like getting an oil delivery, and you just you just walk away. It's the first ASME approved Wiesmann wood pellet boiler installed in the United States. Northeast Plumbing and Heating built it on site for us. It's fully automated. Let me just walk you through it. This is the auger that brings the pellets from the silo. This is the mechanism that controls it. So there are a number of controls, a number of things that have to happen correctly. Anything that's wrong, any jam, we haven't had one. If this is not full of water, it won't allow the auger to come on. This is the dousing unit. I'll talk about it in a moment. There's a brass plate you can see over here that shuts off, that prevents the condition called burnback. Once that auger shuts down, this thing closes right off, so that there's no way for any air to get back from the combustion chamber into this auger. This is the automatic ignition system. They call it a hairdryer on steroids. In 2004, we understood that the system that we had designed meant a major commitment of time from my staff for using wood pellets. So we had to start the tarms. We had to empty the ash out of the tarms. They did shut off by themselves, but they wouldn't start again. But you had to come in and clean out the ash periodically. This system that you see right here, the secondary auger, is an ash disposal unit, and you'll see some photo cells down on the bottom, on the bottom side of this auger tube. As soon as that photo eye can't see from one end to the other, it empties the ash out of the bottom of the unit. It really is phenomenal. We've cleaned it twice this winter. We've cleaned the boiler itself. It's probably due right now. Let's take a look and see what's happening in there. No, it's too hot. But you could, if it was down a little bit more, we could open it up. So, but we can take a look from below. But I could see it definitely needs to be cleaned. If the power goes down and the thing's under load, this is a sending unit inside that opens up a valve from this bucket, believe it or not. And the water from the bucket drains down and soaks the fire. At the same time, there's a solenoid right here that opens up. When it begins to overheat, cold waters run through the steel boiler and right out the side of the building right here, cooling it down as quickly as possible.
So what's inside? So the flame's on the whole bed of this thing? Or what's it look like inside?
The flame is down on the bottom and it shoots up through that tube.
The whole length of it? Or?
No, it's just right in this front. The heat transfer is right in the front. The ash, the smoke, the gases go out through.
So where's the water go in and come out?
The header pipe brings it off and takes it through this heat transfer tank. So none of the water in the boiler goes anywhere. Just goes right here, stays right here.
Goes right into here.
That's right.
And then
And then it heats the coil inside, and that heats the lines.
these lines right here?
Yep. And they take the heat out to the buildings. These are air tubes that shoot. I think it's 3 tubes at a time, three heat transfer tubes at a time. So each one of these, every 500 seconds, it blows air through and cleans the heat transfer tubes. And that was what the circulator pump was for over here. It's all monitored by that little control panel. Tells you what the CO2 level is right coming out of the chimney. Monitors everything coming out through.
Will this run all summer?
Yes. Yeah.
It'd be fun someday when it's off to take a look inside.
Absolutely, anytime. It's off a lot because it just heats this tank up. Once it's satisfied, this thing goes down.
When it's on in the summer, it's heating hot water for showers and stuff like
Correct.
that? Or,
Yep. Yep.
Is it an efficient way to provide hot water for showers?
We'll have that information soon. It's a lot cheaper than electricity. That's for sure.
How big is
Basically,
a big system to heat a few showers every now and then?
We're heating this. All we're
Yeah.
heating is this.
But I mean, you got to take hot water from here and run all through those pipes, so those pipes have to be hot.
How big's the
For shower
pipe
to get hot.
inside all the inside? How much of that's
I think it's
insulation?
1.5 inch. But the amount of energy we're using to heat hot water is only slightly less than the amount of energy that takes to space heat the buildings for the entire year.
Really?
Yes. Oh, it's
Wow,
only
that's incredible.
slightly less. It's almost equal to the amount of energy it takes to heat the buildings.
Is part of that in the winter that when people use hot showers, they're actually heating the building too?
I'm sure it's negligible. We could figure out what it is. What we do have heat recovery systems on the waistlines, so we're gaining a lot of the heat back. We're hoping like 80% of the heat we're getting back. We've got cold water coming in. You're showering with hot water, and you know the physics of it goes around and it doesn't go straight down the tube. It goes around and around and around and around and around. So we've got cold water going around and around and around against hot water going out, and so we're preheating that. We're stealing that heat coming back in. We have made it extremely difficult to switch over. You can see we do have backup propane. You can't just flip a switch in order to switch over from wood to propane. You've got to come down. There's a whole bunch of galleys through here that some have to be closed, some have to be opened in order to do it. So it's difficult. So we're going to use wood. We're committed to wood pellets as much as possible. If we do go down, I'm embarrassed to say we can go to propane, but it's the only building on campus that we can. We don't have any backup for our oil.
Why do we choose to have a backup system here?
We had to. Well, we did. The board voted no. And then because we had to wait for this to get approval, we had to have something to heat them. And I have to say, there's been 2 times where we were lucky to have it. But we don't have it anywhere else, which is sort of the ultimate contradiction. We don't trust wood, but we do trust oil.